Greetings to all. I'm Karthik Raja. My team members are Jayakumar, Gobinath, and Boobalan. And our project domain is Internet of Things. And project title is Smart Farmer IoT enabled smart farming application. The problem statement of our project is when the farmer uses the automated irrigation system, the automated irrigation system could sometimes could lead to the over irrigation. So our proposed solution is using IoT in the agriculture system, the farmers will be able to monitor the moisture, temperature, humidity from any remote locations. And the farmers could also able to control the motor pumps for the irrigation using the mobile application and web application itself. And the technology, this is the technological architecture of our project. When the sensor data is generated, the data is transferred through using Python to the IBM WhatsApp and Node-RED. And from the Node-RED to the web application and mobile application, the user could able to monitor and control the parameters in the field using the web application and mobile application with the help of Node-RED. And as a part of the as part of development phase, in sprint one, we have created a Python code to connect with the IBM Watson platform. In IBM platform, we had to create a device type which provides the organization, device type, and device ID and authentication token. By by including the organization and device type in authentication to in the Python code, we could establish the connection to the IBM Watson platform. And the data is generated using the random functions for the soil moisture, temperature, and humidity. And the data is published. When the code is run, the data is established with the IBM Watson platform. Like connection is successful. In IBM Watson platform, we could visually see the data transferred from Python code to the Watson platform. Like soil moisture, temperature, and humidity is received in IBM Watson platform. When the IBM Watson as a part of a sprint 2, the Node-RED is created, and the Node-RED is created and connected with the IBM Watson platform. The parameters which are received from the Python code like moisture, temperature, and humidity is transferred to the Node-RED. And using the IoT switch, we receive the data from the IoT Watson platform and display in the form of gauge. In the dashboard, we can visually see the temperature, humidity, and moisture in the form of gauge. And sprint 3, we had to create the motor switches to control the motor use Node-RED. And the switches are created and connected with the IBM Watson platform to transfer the command to the from Node-RED to the Python. And in dashboard, we can visually see the switches of motor on and off. When the motor is on, clicked, the Python code shows the command the motor is switched on. When the motor is switched off, the command shows the motor is switched off. And this is the part of sprint 3. In sprint 4, we had to create both the mobile application and web application. And we also included the motor status to visually see the status of the motor. When the motor is on, the status shows the motor on, and the status shows motor off when the motor is on. And in a mobile application, one second. This is the mobile application. We can also control using the mobile application. The mobile application shows the temperature, humidity, and moisture generated using the random data in Python. And it also has the control switches to control the motors. When the motor is on, the motor on is displayed in the status, and the motor is off, the status will changes to motor off. So by this way, the farmers could have the ability to control the field's parameter and the motors on and off from the remote locations. So that farming is under the automated irrigation system within the control of the farmers. Thank you.